Yes, now I hope that we're going to have Mr. Orr back on the screen any moment.
Mr. Chairman, I hope I am on the screen.
Ah, thank you, Mr. Orr. You are just about, yes, you're now full size on the screen. Right, are you ready to carry on?
Yes, I am. Thank you.
Good, thank you. Well, then off you go. Thank you very much.
Thank you. So I'm now turning to my fourth topic, which is the supply of the Celotex products used in the refurbishment. And I start with RS 5000. Now, prior to August 2014, Celotex marketed no products for use in buildings over 18 meters. In May 2014, a cladding system incorporating RS 5000 was successfully tested to BS 8414 by the Building Research Establishment. Following that test, Celotex marketed RS 5000 for use in multi-component rain screen cladding systems from August 2014 onwards. The product literature produced by Celotex for RS 5000 included a product data sheet, a rain screen application data sheet, a specification guide, and a cladding compliance guide. This literature made the following 6 points clear. First, that ADB2 provided an alternative route to compliance for cladding systems through meeting the performance criteria in BR135 by testing to BS 8414. Second, that a BS 8414 test was a system test. To achieve classification under BR135, the cladding system must have been tested to the full test duration requirements of BS 8414. Third, that a classification under BR135 applies only to the system as tested and detailed in the classification report, and that when specifying or checking a system, it is important to check that the classification documents cover the end-use application. Fourth, that RS 5000 had been incorporated in a rain screen cladding system, which had been successfully tested to BS 8414 and met the performance criteria in BR135. As a result, RS 5000 was suitable for use in buildings over 18 meters. Fifth, however, that this fire performance and classification only related to the rain screen cladding system tested to BS 8414. And finally, sixth, that any changes to the components of the cladding system listed in the product literature would need to be considered by the building designer. Now, those points clearly identified for building designers and contractors the matters they would need to bear in mind if using RS 5000 in a cladding system on a building over 18 meters. Indeed, the rain screen cladding compliance guide explained that it provided a step-by-step guide to an alternative route to compliance for ADB2. And could I ask to have that put on the screen? It is CEL 0000, that's 4 zeros, 1239. And if we could start by going to page 2 of the document, and if we could zoom in on the upper part of the document, it's the paragraph exactly there. Now, what that paragraph says is what I've just said, that this guide provides a step-by-step guide to an alternative route to compliance for ADB2. And then if we could move to page 3, and if we could zoom in on the top right-hand part of the document, the third column of text says the performance of the system under investigation is evaluated against 3 criteria: external fire spread, internal fire spread, mechanical performance. And then it goes on to say, the classification applies only to the system as tested and detailed in the classification report. The classification report can only cover the details of the system as tested. It cannot state what is not covered. When specifying or checking a system, it's important to check that the classification documents cover the end-use application. And then if we could go to the fourth and final page of this document. So it is a relatively short document and not difficult to read or comprehend. Again, on the top of the document, the third, in the second column, there's a heading Celotex RS 5000. That then sets out a description, which it says comprises the system tested. And then in the final column of text, again, it repeats the warning that any changes to the components listed and construction methods set out in Figure 4 will need to be considered by the building designer. And then finally to note that on the bottom of this page, the compliance guide, if we could move down to the bottom part of the page, the compliance guide contains a bibliography which lists the ADB2, BS8414 and BR135 guidance. Thank you. So moving on then from the literature itself, what is important to note is that it was Celotex's policy and practice always to send out the rain screen cladding compliance guide, which I've just explained, when responding to queries about the use of its insulation in buildings over 18 meters. This information was therefore widely disseminated among customers and potential customers, and indeed it was shared with Harley, as I will come on to describe. The consequence is that any construction professional who read the Celotex product literature would have known that the BR135 classification achieved by RS 5000 applied only to the cladding system tested by Celotex, and any changes to the components of the system described in the product literature would need to be carefully assessed in order to ensure that the product was suitable for use in a system with different components. The product literature also referred to other performance characteristics of RS 5000, including its BREEAM rating and its Class 0 classification. That should not have been a cause for confusion. As any competent construction professional should have known, Class 0 is not relevant to determining compliance of insulation used in the rain screen cladding system on a building over 18 meters, albeit that it can be a relevant indicator of a product's reaction to fire for other purposes. At this stage, I need to refer back to the investigations carried out by Celotex after the Grenfell Tower fire. In the course of those investigations, Celotex's current management learned that there were certain differences between the rain screen cladding system incorporating RS 5000, which had been tested by the BRE in May 2014, and the description of that system in the BRE's test and classification reports issued following the test and described in the RS 5000 product literature. This is fully addressed in the summary paper which Celotex provided to the inquiry as an appendix to Mr. O'Sullivan's witness statement. Once this issue had come to the attention of Celotex's current management, it was announced on Celotex's website and reported to the relevant authorities and the inquiry, as I've said. It involved unacceptable conduct on the part of a number of former employees. The tested system should clearly have been described accurately in both the BRE reports and in Celotex's product literature. In order to determine whether the misdescription of the test system gave rise to any safety issues, Celotex commissioned another BS8414 test, replicating as closely as possible the system described in BRE reports and the RS 5000 product literature. This further test was carried out in April 2018. It showed that the retested system met the performance criteria in BR135. The results of this test were announced to the market and others on the 2nd of May 2018. Celotex accepts, as I've said, that the system tested in May 2014 should have been accurately described in the product literature and the BRE reports, and I've explained the steps that Celotex took when this issue was discovered by its current management. However, there's no reason to believe that the misdescription of the tested system had any impact at all on the specification and use of RS5000 in the Grenfell Tower refurbishment. The rain screen cladding system described in Celotex's product literature and in the BRE reports, as well as the system actually tested in May 2014, was so substantially different from the rain screen cladding system installed on Grenfell Tower that the BRE's certification of RS5000 was simply not relevant to the external wall construction at Grenfell Tower. As a result, no construction professional could have relied on the BRE reports or Celotex's product literature as demonstrating compliance of the rain screen cladding facade at Grenfell Tower. This was confirmed by Dr. Lane in her Phase 1 expert report. It has also been confirmed by Mr. Hyatt in his expert evidence this week. It is, moreover, clear from the evidence of the Studio E, Harley and Ryden witnesses in Module 1 that no reliance was in fact placed by any designer or contractor on the description of the tested system in Celotex's product literature or the BRE classification report. That evidence is addressed in paragraphs 52 to 72 of Celotex's written opening submission, together with the evidence of Celotex's role in the specification and supply of RS5000 for use at Grenfell Tower. That is the issue to which I now turn. There are 4 key points I would like to mention here. First, Celotex FR5000 was specified for use in the Grenfell Tower project in 2012. That was before the launch of RS5000. FR5000 was not marketed for use in buildings over 18 meters. It was specified for Grenfell Tower without Celotex's knowledge and without any communication with Celotex. It appears to have been identified for the project by Max Forden and incorporated into the NBS specification by Studio E without any regard to fire safety or compliance with ADB2. Second, Celotex was first contacted by Harley about the use of insulation for Grenfell Tower in June and July 2014. At that stage, Celotex informed Harley that it did not yet have a product suitable for consideration on a building over 18 meters. Third, after the marketing launch of RS5000, Mr. Room, who was then Celotex's major projects and specification manager, sent Harley a full set of the RS5000 product literature, including the rain screen cladding compliance guide. As a result, Harley had more than sufficient information about RS5000 to understand what factors it would need to consider when assessing compliance of the rain screen cladding system that it was designing and installing at Grenfell Tower. Fourth, in February 2015, there were a number of further email exchanges between Celotex and Harley. These concerned the calculation of U values, which are relevant to determining the thickness of insulation required for a rain screen cladding system. They were not concerned with determining compliance of the cladding system with building regulations. That, as I've said, was not something on which a product manufacturer could advise and was not Celotex's responsibility. Now, the evidence given in Module 1 shows that despite Celotex having made its product literature available to the designers and contractors involved in the Grenfell Tower refurbishment, none of them read that information with any care, if they read it at all. With 2 exceptions, the Harley and Studio E witnesses all confirmed that they did not read the literature at all, or if they did read it, They acknowledged that they did not do so carefully. They consequently paid no heed to the warnings given by Celotex about the need to ensure that any changes from the tested system described in Celotex's product literature were considered by the building designer. The two exceptions that I need to mention are Mr. Ray Bailey, who was the sole director of Harley, and Mr. Crawford of Studio E. Mr. Ray Bailey suggested that he had relied on a Celotex sales brochure, but it is apparent, we say, from his evidence that insofar as he read any of the Celotex product literature, he didn't do so carefully. He claimed to have relied on a reference in the product literature to RS5000 having class 0 fire performance throughout, but that was irrelevant to assessing compliance of the insulation for a cladding system in a building over 18 meters, as I've explained. Mr. Ray Bailey also claimed in evidence that Celotex had signed off on the use of RS5000 at Grenfell Tower after carrying out a desktop study, and he claimed that that desktop study had been given to Mr. Anquetel Jones, who was Harley's design manager. However, no such desktop study has been disclosed by anyone to this inquiry, and Mr. Bailey admitted in further questioning that he had never seen such a study. His evidence about Celotex signing off on the use of RS5000 and providing a desktop study to Harley was denied in turns by other Harley witnesses, including Mr. Ben Bailey and Mr. Anquetel Jones. Mr. Ben Bailey said that he was given no assurances by Celotex as to the use of RS5000 in combination with the cladding panels used at Grenfell Tower. Mr. Anquetel Jones, who indeed was the person within Harley with primary responsibility for ensuring compliance of the rain screen cladding system, confirmed in his evidence that he had no discussions with Celotex about the suitability of RS5000 for Grenfell Tower, and that he was unaware of any desktop assessment having been carried out for the Grenfell Tower project. So far as Mr. Crawford is concerned, he claimed in evidence that he had been misled by the RS5000 datasheet. However, we submit that his evidence cannot be reconciled with his witness statement, where he said that he had no specific recollection of reviewing the datasheet. Mr. Crawford also could not explain how he had failed to appreciate the need to assess differences between the system proposed to be installed at Grenfell Tower and the system tested by Celotex if he had in fact read Celotex's product literature. The inquiry may consider that the evidence given by Mr. Ray Bailey and Mr. Crawford on these points was unsatisfactory and self-serving. Celotex submits that it was not credible and is not reliable. Ryden, however, tries to rely on the evidence of Mr. Ray Bailey and Mr. Crawford to argue in its written opening submission that Celotex is responsible for the specification and use of RS5000 at Grenfell Tower, rather than the designers and contractors. This, in our submission, is a misplaced attempt by Ryden to avoid responsibility for its own failings and the failings of the designers and contractors for which Ryden is liable as the main contractor on the project. In considering Ryden's argument, it is necessary to bear in mind the nature and extent of Ryden's own responsibility for the non-compliance of the cladding facade at Grenfell Tower. As the main contractor, Ryden was contractually obliged to design and carry out the refurbishment works in accordance with the building regulations. Although Ryden engaged Studio E and Harley as subcontractors, it remained responsible as the main contractor for the design and construction of the rain screen cladding system and for ensuring that that system complied with building regulations. Despite this, Ryden had no experience or capability to ensure that the cladding system was compliant. No one at Ryden working on the refurbishment, or it would appear in Ryden more generally, had any knowledge or expertise in relation to fire safety, facade design and construction, or regulatory compliance. Ryden's witnesses also admitted that despite Ryden relying completely on subcontractors to ensure compliance with building regulations, Ryden had no processes to satisfy itself as to the competence of the subcontractors that it used. As a result, neither Studio E nor Harley were subjected to any adequate due diligence process before they were engaged by Ryden. To compound matters, Ryden decided not to engage Exeter or any other fire safety consultant on the Grenfell Tower project, despite Mr. Lawrence, who was Ryden's contracts manager, acknowledging in his evidence that a fire safety consultant was essential on projects of any complexity. It appears that this decision by Ryden was driven by its desire to cut costs, which was a major consideration for Ryden on this project, given its miscalculation when tendering, which meant that its bid was understated by more than £200,000. Ryden's attempt to shift responsibility onto Celotex for its own failings is, Celotex submits, misconceived. The evidence of Mr. Ray Bailey and Mr. Crawford is unreliable for the reasons I have given. That evidence cannot be taken at face value or to demonstrate reliance by Harley or Studio E on anything said by Celotex in its product literature. Ryden also relies on the evidence of Mr. Hoban, who was the RBKC building control officer responsible for checking compliance of the Grenfell Tower refurbishment works. However, Mr. Hoban's evidence does not support Ryden's argument. It does not, we submit, demonstrate any meaningful reliance on anything said by Celotex in its product literature. Rather, it demonstrates Mr. Hoban's complete failure to carry out his function as a building control officer with any degree of competence. Mr. Hoban was assigned to the Grenfell Tower refurbishment despite having a full workload and being very ill-equipped for the role. He had no previous experience of high-rise residential overcladding projects. He had received no training on fire performance in external wall construction or the fire safety classification of cladding materials. He did not know what a BS 8414 test was, and he had never read BR 135. He told his line manager, Mr. John Allen, that he was overstretched and he asked for help. However, he was given no help. Although Mr. Hoban said he had checked the suitability of the insulation used in the rain screen cladding system, his evidence on this was very confused. He said that he had looked at either the Celotex or LA or local authority building control websites, but he was unsure which website he had viewed, and he could not explain what information he had looked at on either website. Insofar as he saw anything, it is clear from his evidence that he gave it no careful consideration. In fact, he admitted that he never investigated precisely why RS 5000 was suitable for use in a building over 18 meters, and he accepted that that was a serious failing on his part. When giving evidence last week, Ms. Menzies was particularly critical of Mr. Hoban's failure to check compliance of the products used in the cladding system. She said that interrogating product literature was a core function of a building control officer, and that Mr. Hoban should have understood that BS 8414 was a system test, and that he therefore needed carefully to check the precise combination of materials used in the cladding system. Mr. Hoban, however, did not do that. In short, Ryden's attempt to shift responsibility onto Celotex is without merit and should, Celotex submits, be rejected. This brings me to TB 4000. I can deal with this shortly. TB 4000 is a general purpose insulation board. It is invariably bought in large quantities and different thicknesses by distributors and builders merchants as a stock item. In December 2017, the inquiry informed Celotex that TB 4000 had been found in window surrounds at Grenfell Tower. The product had apparently been glued to the underside of UPVC windows. It appears that the TB4000 used at Grenfell Tower had been purchased by ST Plastering, one of Ryden's subcontractors, from a Travis Perkins outlet. Celotex did not know and had no means of knowing that TB4000 was purchased and used at Grenfell Tower in this way. The decision to use TB4000 seems to have been taken by Ryden in consultation with ST Plastering. The decision appears to have been based on the product's perceived ability to prevent bowing of window surrounds, but without any regard to fire safety. Neither Ryden nor ST Plastering considered whether use of TB4000 in the window surrounds was compliant with the building regulations or the guidance in ADB2. Mr. Lawrence, who as I've said, was Ryden's contracts manager, he admitted in evidence that Ryden was itself responsible for ensuring that use of TB4000 in the window surrounds complied with building regulations, because he accepted there was no other designer involved in that aspect of the refurbishment on whom Ryden could rely. This was therefore all down to Ryden. However, neither Mr. Lawrence nor anyone else at Ryden investigated whether TB4000 was in fact suitable for use in the window surrounds. As a result, Mr. Lawrence did not know that TB4000 was not a material of limited combustibility, and he did not know that it could not be used in the exterior wall construction unless the construction was shown to meet the performance criteria in BR 135 or a holistic fire engineering analysis was undertaken. In short, we submit that responsibility for the non-compliant use of TB4000 lies squarely with Ryden and not with Celotex. Finally, Mr. Chairman, I would like to say a few words about Arconic. Arconic manufactured, marketed, and supplied the Rainabond PE panels used as the cladding facade at Grenfell Tower. The inquiry has already found in its Phase 1 report that these panels were the principal reason for the devastating spread of fire up, down, and around the tower on the 14th of June 2017. These panels were made of aluminium composite material, and they had a core of unmodified polyethylene. Polyethylene is highly flammable. Unlike PIR, which could safely be used in compliance with the building regulations in a cladding system with an appropriate combination of other components, Rainabond PE could not safely be used in any cladding system on a high-rise residential building. That was demonstrated by the BS 8414 tests carried out by the Department for Communities and Local Government following the Grenfell Tower fire. Those tests showed that the cladding system cladding systems incorporating ACM panels with the PE core failed to meet the BR 135 criteria, irrespective of the kind of insulation with which the panels were combined. The tests failed even when non-combustible mineral wool insulation was used in a cladding system with ACM PE panels. By contrast, the tests carried out by the Department for Communities and Local Government showed that a cladding system combining Celotex RS5000 with an ACM panel with a Class A2 filler did in fact meet the BR 135 criteria. The experts appointed by the Department for Communities and Local Government accordingly concluded that PIR insulation could safely be used in a cladding system with Class A2 panels on residential buildings at any height. Now, although Rainabond panels with an A2 core were available at the time of the Grenfell Tower refurbishment, Arconic did not actively promote them. The evidence suggests that Arconic did not do so because it was concerned to ensure that its products remained competitive in the UK. and its Rainabond PE panels were cheaper than panels with an A2 or fire retardant core. Arconic's documentary and other evidence is summarized in Celotex's written opening submission at paragraphs 85 through to 112. The Arconic evidence is summarized to the same effect in the written opening submissions of the two BSR legal teams. That evidence shows that over an extended period, Arconic misled both the BBA and the market about the true fire performance of Rainabond PE panels. The story begins with Arconic's concealment of the results of a test it had carried out of Rainabond PE in cassette form when it applied for a certificate from the BBA in respect of Rainabond. Tests carried out by Arconic in 2005 under European standards had revealed a significant disparity between the fire performance of Rainabond PE in rivet form, which achieved Class B, and Rainabond PE in cassette form, which failed the test completely and could only be classified as Class E. It was Rainabond PE in cassette form that was used at Grenfell Tower. Although Arconic was required by its contract with the BBA to disclose full particulars of all test data available on Rainabond, it provided the BBA only with copies of the test report for the rivet variant. It represented to the BBA that that test result was representative of the fire performance of Rainabond PE, however the product was fabricated. As a result, when the BBA issued its certificate in 2008, it certified that Rainabond PE could be regarded as having a Class 0 surface based on the Class B classification achieved by the rivet variant. The BBA has confirmed in witness statements provided to this inquiry that if it had known that the fire performance of the cassette variant was different to that of the rivet variant, it would have based its certification of Rainabond PE on the Euroclass test results for each variant of the product. In that event, the cassette variant would have been restricted to buildings of less than 18 meters in height. The cassette panels could therefore not have been used at Grenfell Tower, and the tragedy of the 14th of June 2017 would not have occurred. Now, further Euroclass testing carried out by Arconic after the issue of the BBA certificate confirmed that the cassette variant only ever achieved Class E. Those tests also demonstrated from 2014 onwards that the rivet variant only achieved Class C. As a result, from 2014 onwards, the product could not be said to have a Class 0 surface, whatever its form of fabrication. Despite this, Arconic continued marketing Rainabond PE in the United Kingdom as having a Class 0 surface on the strength of the BBA certificate. Throughout this period, Arconic ignored increasingly strident warnings from Mr. Verler, the head of Arconic's sales technical support team, about the dangerous nature of Rainabond PE and the unsuitability of the product for use on any building facade of whatever height. Mr. Verler urged the company's management to move all of its ACM business to fire retardant panels, but his advice was rejected, apparently on the ground that it was regarded by Arconic's management as technical and anti-commercial. And I quote there from an internal Arconic email of the 29th of June 2015. Arconic steadfastly refuses to acknowledge any deficiency in its approach to the testing, marketing, and supply of Rainabond PE. Celotex submits that the position Arconic has adopted in its opening for Module 2 is untenable. I make the following particular points. First, Arconic appears now to acknowledge that a cladding system incorporating Rainabond PE would not pass a BS 8414 test. However, Arconic continues to argue that the specification and use of Rainabond PE at Grenfell Tower could theoretically be justified by a holistic fire engineering report. That is completely unrealistic given the fire propagation characteristics of Rainabond PE. Second, Arconic argues that it was neither necessary nor relevant for it to provide the 2005 cassette test result to the BBA when applying for a certificate from the BBA. That is simply untenable. Arconic's contract with the BBA expressly required disclosure of all test data then available, as I've said. Third, Arconic argues that once the BBA certificate was issued, there was no need for additional fire performance information regarding the surface of Rainabond PE to be disclosed to the BBA unless the fire performance of the surface of the product had changed, which it did not. That also is untenable. Arconic was expressly obliged by its ongoing contracts with the BBA immediately to notify the BBA of any new or additional information concerning Rainabond PE. Fourth, Arconic argues that it was not in a position to determine if the state of the UK regulatory regime was such that continued sale of Rainabond PE was problematic, and that it was entitled to rely on what it describes as its belief that its product would be used in a safe manner. That also is untenable in the light of the extensive documentary evidence showing that Arconic knew that Rainabond PE was unsafe and should not be used on building facades. Arconic's documents show that it deliberately sought to leverage the difference between UK and European fire safety standards so as to continue selling Rainabond PE in the United Kingdom after it had been forced to stop selling that product in countries that applied European standards. Arconic claims in its written opening that it has from the outset endeavoured to cooperate with this inquiry, both as regards the provision of information and as regards oral evidence. However, Arconic appears to be hiding behind the French blocking statute to prevent its witnesses from attending to give evidence before this inquiry. This makes Arconic's claim of cooperation a hollow one. Arconic's stance is odd, given that it specifically sought and obtained an extension of the Attorney General's undertaking in March 2020, on the ground that Arconic's witnesses would be giving evidence on behalf of the company, and that the company therefore also needed the benefit of an undertaking from the Attorney General. Arconic's reliance on the French blocking statute is, we suggest, plainly inappropriate, given the public importance of the issues being examined by this inquiry, and the major role that Arconic's cladding panels played in the spread of fire on the 14th of June 2017. It is a matter of deep concern to Celotex that Arconic should be seeking to hide behind the French blocking statute in these circumstances. Celotex urges the inquiry to continue its efforts to achieve a resolution of this matter with the French authorities. It also invites Arconic to abandon its reliance on the French blocking statute so as to demonstrate that Arconic truly is intent on cooperating with this inquiry. So that only leaves it to thank you for this opportunity to make this opening statement.
Well, thank you very much, Mr. Orr. It's been very helpful and interesting to hear what you have to say. Thank you very much indeed. Right, the next statement is going to be made by Mr. Webb on behalf of Kingspan. So perhaps he could come up on the screen. Good afternoon, Mr. Webb.
Good afternoon.
You can hear me and see me all right, can you?
Yes, I can, sir.
Good, thank you. Well, we can see you and hear you very well, so please make your statement on behalf of Kingspan. Thank you.
Mr. Chairman, members of the panel, This is the first time that Kingspan Insulation Ltd has made an oral statement to the inquiry. This module will also be the first time that any of the employees of the company have given evidence to the inquiry. The first thing I wish to say is that everyone at Kingspan Insulation has been deeply shocked by the devastating and appalling tragedy of the 14th of June 2017. It is a tragedy which resulted in the death of 72 individuals and the terrible suffering of so many other people. I speak on behalf of all those employed by the company and its representatives when I say that we all wish to express our profound sorrow that this disaster occurred and to offer our deepest sympathies to the bereaved families, the survivors, the residents, and to everyone affected by the tragedy. It was a tragedy that should never have happened. Kingspan Insulation welcomes and supports the vitally important work of this inquiry in its efforts to determine what went wrong and why. The company has worked hard to respond fully to all of the questions asked of it, and it will continue to do so. Kingspan Insulation has set out its position concerning the content of Module 2 in its detailed written opening statement. That opening statement draws upon the evidence provided in 15 witness statements and over 21,000 documents provided by the company to the inquiry. Although Kingspan Insulation had no knowledge until after the tragedy that any of its insulation had been used in the refurbishment of the facade of Grenfell Tower, it's now clear that a limited amount of K15 phenolic insulation product was used during the refurbishment when there were gaps in the availability of the specified insulation, Celotex RS5000 PIR. It's also now clear that another of its insulation products, TP10, was used in some window reveals. The company has looked in detail at its processes and procedures and has identified some important process shortcomings, particularly in relation to the way that 3 BS8414 tests, one undertaken in 2005 and 2 in 2014, were conducted and relied upon for the marketing of K15. However, further testing undertaken in 2015, 2016, and since the fire has supported and validated the performance claims made historically in respect of those 3 earlier tests. The company is confident, therefore, that at the time of the Grenfell Tower refurbishment, these shortcomings did not affect the safety of any cladding system incorporating K15, which relied upon those 3 BS8414 tests. Nevertheless, the shortcomings should not have happened, and Kingspan Insulation offers a full and sincere apology for them. These issues have been set out in the witness statements of the company's employees and in its written opening statement. Kingspan Insulation also wishes to make 2 important submissions at the outset, which are dealt with more fully in section F of its written statement. First, testing and peer-reviewed research carried out since the tragedy indicates that the PE-cord ACM cladding used on Grenfell Tower was unsafe and should not have been used on tall buildings. Second, the testing and research carried out indicates that the devastating spread of the fire was caused by the presence of that PE-cord ACM cladding, and that the outcome of the fire would not have been different in any material way if non-combustible mineral fibre insulation had been used behind that cladding instead of PIR. The company welcomes the detailed consideration of these important issues, including by the experts instructed by the inquiry, in the coming modules. We recognise that the inquiry is a dynamic process where evidence is heard and examined, and that core participants will have an opportunity to comment upon that evidence in closing submissions. However tempting it might be to respond today to certain points raised in the opening statements of others, we will wait until the actual evidence has been heard in full and will respond to that evidence by way of closing submissions in due course. My oral statement today will therefore be short and will focus on the following 6 points. First, who is Kingspan Insulation and what is K15? Second, how did K15 come to be used in the refurbishment? Third, how did PE-cord ACM cladding come to be used on Grenfell Tower? Fourth, what issues arise from the fact that such cladding and such insulation were used? Fifth, the testing, certification and promotion of K15. And sixth, what Kingspan Insulation has done since this tragedy. So turning to the first point, who is Kingspan Insulation and what is K15? Kingspan Insulation is a company within the Kingspan Group responsible for the sale of Cooltherm K15 insulation in Great Britain. K15 is a type of rigid board insulation made from phenolic foam. Insulation is a vital part of any construction, both for environmental reasons and for the health and comfort of its residents. And it's widely accepted in the industry that insulation should be added to buildings during cladding refurbishment. Relevant requirements in respect to the conservation of energy are set out in Part L of the building regulations. The building regulations at the time of the refurbishment of Grenfell Tower permitted the use of K15 on tall buildings, provided that it was used as part of a cladding system which could be shown to be compliant with approved document B or with the BCA Technical Guidance Note 18. As the inquiry has heard, at the relevant time, approved document B provided for 3 routes to compliance for any cladding system. The so-called linear route to compliance could be used if the insulation was classified as limited combustibility or as non-combustible. K15 was not classified as either, and so could not have been used under the linear route. There were 2 other routes to compliance in approved document B. The second route required that the particular cladding system meet the criteria given in BR 135 when tested to BS 8414. The third route required assessment of the building as a whole by a fire engineer. The BCA Technical Guidance Note 18 also allowed compliance via desktop study. It is clear that none of these 4 routes were followed by those responsible for the design of the refurbishment of Grenfell Tower. Furthermore, as was concluded in the Phase 1 report, the functional requirement set by B4.1 of Schedule 1 of the building regulations, which requires that the external walls be adequately resist the spread of fire, was not met. As was noted in the report, this was a submission that had been made by Kingspan Insulation in its Phase 1 closing submissions. It's important to note that Kingspan Insulation was not asked to provide, and did not provide, any advice to those responsible for the refurbishment about the suitability of K15 for use on Grenfell Tower with PE-cooled ACM cladding. Indeed, the company did not know that any of its K15 product had been used on Grenfell Tower until after the fire had occurred. That brings me to the second issue: how did K15 come to be used in the refurbishment? The first point to note is the insulation specified by those responsible for the refurbishment of the Grenfell Tower was Celotex RS 5000 PIR and not K15 phenolic insulation. Since the fire, Kingspan Insulation has learned, and the inquiry has heard, that there appear to have been supply problems in respect to the Celotex product during the refurbishment, and that in total 145 sheets of K15 were delivered by third-party suppliers, SIF and CCF, to Grenfell Tower because of short gaps in the availability of Celotex RS 5000. Some of those K15 sheets were supplied in May and the rest in September 2015. On the information currently available, it appears that K15 constituted 5.2% by area of the rain screen insulation boards ordered for use in the refurbishment. As I've said, at no stage did anyone involved in the refurbishment ask Kingspan Insulation for advice as to whether K15 should be used on the tower with PE-cooled ACM, and the company had no knowledge that K15 had been used until after the fire. The only contact that seems to have been made with Kingspan Insulation in respect to the refurbishment was a request for a single U-value calculation in July 2012. That is a calculation of the thickness of insulation needed to meet a specified thermal performance requirement. That request made no reference to the type of cladding being proposed. Kingspan Insulation heard nothing more and had no other contact with those responsible for the design of the refurbishment. As we know, a decision was subsequently made to use the Celotex PIR product. As I said, K15 was not classified as either non-combustible nor of limited combustibility, and so could not be used in the refurbishment via the linear route to compliance. There was nothing in any of the K15 product literature or third-party certification current at the time of the refurbishment which stated that K15 could be used under the linear route. In short, no steps appeared to have been taken by those responsible for the refurbishment to consider whether PIR or K15 could be used in conjunction with PE called ACM in a manner which was compliant with approved document B or technical guidance note 18. Had that vital question been considered, the conclusion would have been that PE called ACM could not be used with the Celotex product or K15 unless verified by a full-scale testing, a desktop study, or a whole building fire engineering assessment. None of those routes were followed by those responsible for the refurbishment. The third issue which arises is this: how did PE cord ACM cladding come to be used on Grenfell Tower? Kingspan Insulation's understanding of the evidence so far is that the BBA certificate for the PE cord ACM cladding used in the refurbishment stated that it achieved Euroclass B. The effect of this is that in principle, the linear route to compliance permitted the use of PE cord ACM cladding on tall buildings without any further testing or fire engineering assessment, provided that it was used in conjunction with non-combustible or limited combustibility insulation. But the fundamental issue here is that following the Grenfell Tower fire, the testing commissioned by the Department for the Communities and Local Government demonstrated that the PE cord ACM cladding failed the large-scale BS 8414 fire tests, both when combined with PIR insulation and when combined with non-combustible synthetic mineral fibre insulation. And these were not marginal fails. They were out-and-out failures of the test. Both systems failed in under 8 minutes because of flame height. In other words, despite its apparent Euroclass B classification, the PE cord ACM cladding system used for Grenfell Tower was incapable of meeting the safety standards set by BR 135, regardless of whether non-combustible mineral fibre insulation or PIR insulation was installed behind it. This strongly indicates that the PE cord ACM cladding was not safe for use, regardless of the type of insulation with which it was combined. The fourth issue is this: what issues arise from the fact that PE cord ACM cladding and PIR and phenolic insulation were used in the refurbishment? The first question which arises here, and which this module will be exploring, is how and why the PE cord ACM cladding could ever have been certified as Euroclass B, when in fact it failed, and failed so badly, to pass any of the large-scale BS 8414 fire tests, regardless of the type of insulation used behind it. The second question, therefore, is whether the linear route to compliance is fit for purpose, or whether instead it's better to carry out large-scale fire tests to ensure that the cladding system as a whole can meet the relevant requirements of the building regulations. It's appreciated that opinions may be divided on this issue, but Kingspan Insulation believes that one of the lessons to be learned from this tragedy is that it is inherently safer to test any particular cladding system as a whole, rather than to assume that it will be safe because each component has passed or has apparently passed some smaller scale test. We understand that the value of large scale testing will be considered in Module 6, and we welcome that. The third question which follows from the failure of the PE cord ACM cladding systems to pass BS 8414 tests when used with non-combustible mineral fibre insulation is this: would the nature or speed or spread of the Grenfell Tower fire have been any different had synthetic mineral fibre been used behind the PE cord ACM cladding instead of PIR or phenolic insulation? This third question is, of course, an issue of very real importance, not least in terms of understanding the impact of different insulation types in the cladding fires. The DCLG tests showed that a system using PE cord ACM plus synthetic mineral fibre insulation failed just as quickly as the system using PIR insulation. Furthermore, extensive computer modelling undertaken by independent fire experts, Effectis, and published in a series of peer-reviewed academic papers shows that the influence of the PE cord ACM cladding was so dominant in the Grenfell Tower fire that replacing the PIR insulation with synthetic mineral fibre insulation would not have made any material difference to the nature or extent of the fire. That research was partly funded by Kingspan Insulation, but it was entirely independent of the company. That research also shows that if A2 rated ACM, i.e. limited combustibility cladding, had been used with PIR insulation, then the fire would not have spread over the building facade. It therefore appears to Kingspan Insulation from the evidence currently available that the decision to use PE cord ACM cladding had the gravest possible consequences, regardless of what decision was then taken in respect to the type of insulation to be installed behind it. Ultimately, it will be a matter for the experts instructed by the inquiry to provide their independent opinion evidence on these issues. And we look forward to the inquiry examining these important issues in depth in due course. Fifth, I come to the testing, certification and promotion of K15. As at May 2015, when the first K15 sheets were delivered for use on Grenfell Tower, 4 systems incorporating K15 had been tested to BS 8414 and had successfully met the BR 135 criteria. By the time the second supply of K15 for use in the refurbishment in September 2015, 2 more cladding systems incorporating K15, so 6 in total, had been successfully tested to BS 8414. A further 11 successful BS 8414 tests have been undertaken since September 2015, involving cladding systems using K15. However, the tragedy of the Grenfell Tower fire has caused Kingspan Insulation to review in detail the product development, testing, certification and promotion of K15. As I've said, this review has identified some important process shortcomings, particularly in relation to the way certain tests of cladding systems undertaken in 2005 and 2014 were conducted and relied upon for the marketing of K15. Those issues have been set out in the witness statements provided by the company's employees and have been summarised in its written opening statement. In particular, as to the testing, it's recognised that there were production process changes after the original 2005 BS 8414 test, and that a new test should have been carried out following these changes. However, that 2005 test has now been replicated as closely as is possible using current standard K15, and it passed. It's also recognised that another of the 6 successful tests undertaken by September 2015, namely a 2014 test using a terracotta cladding system, had used a research and development variant of K15, and so that test should not have been relied upon. However, 2 further BS 8414 tests of similar terracotta systems using current standard K15 were undertaken in 2015 and 2016, and both also passed and met the criteria in BR 135. The 4 other BS 8414 tests which had been carried out by September 2015 were all successful tests of cladding systems using current standard K15. Some shortcomings in respect of K15 marketing and product literature have also been identified, which again have been set out in the witness statement and in the opening statement. As at today's date, a total of 15 BS 8414 tests of cladding systems incorporating current standard K15 have successfully met the criteria used by BR 135. That includes 3 tests using A2 ACM panels as well. Kingspan Insulation is confident that ADB compliant cladding systems that incorporate K15 are safe. Furthermore, many regulatory regimes around the world allow the use of suitably tested systems incorporating K15 on tall buildings. It is important to emphasise that a large-scale fire test such as BS 8414 is a test of the entire cladding system. A failed BS 8414 test therefore means that the cladding system as a whole has failed, but it does not necessarily follow that there is a problem with the insulation. An example of this is the failed BS 8414 test carried out in 2007 on a Celotex system using K15. Certain individuals at Kingspan Insulation were naturally very concerned about this failure and expressed their concerns in emails, some of which have been quoted in the written submissions of other core participants. What has received less attention, however, is the fact that a very similar, if not identical, Celotex cladding system was tested shortly afterwards using non-combustible synthetic mineral fibre insulation instead of K15, and that also failed the test. That's set out in paragraph 46 of our written statement. The reality is that such failed tests demonstrate that the BS 8414 system was working robustly in identifying that some cladding systems were not capable of passing the test, regardless of the type of insulation used behind them. The sixth issue I'd like to mention is the initiatives taken by the company since the tragedy. Kingspan Insulation has implemented wide-ranging improvements of its processes and procedures, addressing the specific shortcomings that it has identified historically, but also improving its procedures generally. These changes have been set out in the witness evidence and summarised in the written opening statement provided by the company. They include, briefly, first, improvements to product traceability. Second, the introduction of a new protocol and guidance on fire testing. Third, a review of the marketing literature and performance claims relating to its insulation products. Fourth, the publication on its website of all BS 8414 test reports of systems incorporating standard K15, whatever the outcomes of those tests. Fifth, new marketing protocols. Sixth, a new code of conduct. Seventh, improved technical support provided under the Kingspan Assured Technical Support Programme. Eighth, a new accreditation protocol governing new or amended certification procedures. And ninth, improved change management procedures. Finally, I conclude by saying that Kingspan Insulation is committed to assisting this inquiry to get to the truth as to both how and why this tragedy occurred and what can and should be done to ensure that no future tragedies of this nature can occur. The company will continue to support the work of the inquiry at every step of the way. So, Mr. Chairman, thank you, and thank you for the opportunity to make these submissions.
Well, thank you very much, Mr. Webb. It's certainly been very interesting and helpful to hear from you, so thank you again. Now, the next person to address us is Mr. Sawtell, who's going to make an opening statement on behalf of the British Board of Agrément. So, good afternoon, Mr. Sawtell, you're there.
Good afternoon, sir. Yes, indeed.
You can see me, I can see you, yes?
Yes, indeed.
And we can hear each other, so that's good. Well, would you like to go ahead then and make your statement? I'm sorry we are running a bit late, but I think you shouldn't feel at all under any pressure from me, at least, of time. And we'll take a break after we've completed your opening statement. So when you're ready.
Thank you. Mr. Chairman, Madam, Sir, I represent the British Board of Agrément, and I'm here to provide you with my oral opening submissions. The BBA expresses its deepest sympathy to the bereaved, victims and survivors of the Grenfell Tower fire. As an organisation, it is committed to helping improve construction safety to prevent such a tragedy from occurring in the future. Part of the purpose of the inquiry is to examine the decisions relating to the design, construction and refurbishment of Grenfell Tower. It is also to examine the guidance and industry practice relating to construction works on such high-rise residential buildings. An essential aspect of a commitment to prevent this tragedy recurring is to look critically at these issues and to determine what can be improved. The founding purpose of the BBA was to provide an independent, authoritative source of data on the performance of construction materials and their suitability for use in clearly defined applications. It is in that spirit the BBA has engaged with and contributed to the efforts to prevent such a tragedy happening again. The BBA led evidence to the Hackett inquiry and to the parliamentary committee set up to consider its findings. The BBA is agitated for the full adoption of the Hackett report's findings, which it enthusiastically endorses. The BBA has also provided evidence to the Metropolitan Police as part of their investigation. The BBA has disclosed a number of documents and provided several witness statements to this end. It has been, and it continues to be, ready to provide what assistance it can. To consider what the BBA does. The Agrément board itself was established by the government in 1966, following building failures attributed to the inappropriate use of construction materials. The Agrément board became the BBA in 1982, at the same time as it became a self-funding, non-profit distributing company with no formal government association. Part of the function of the BBA is to issue Agrément certificates in respect of building materials. A certificate states the BBA's opinion as to a product's compliance or contribution to compliance with the particular building regulations noted in the certificate. Fire safety is one part of the contents of a certificate. In the witness statement evidence provided by the BBA, and in particular the first witness statement of John Alban, it describes what the relationship is between a BBA certificate and the relevant building regulations and product safety standards. Each certificate maps the applicable building regulations considered in the BBA's assessment. The building regulations themselves are supported by approved documents which provide guidance on measures to allow a construction to satisfy the relevant regulatory requirements. In terms of fire safety, products are certified by reference to Approved Document B. Approved Document B sets out systems for classifying the reaction to fire properties of a product using either a national or European classification system. It then sets out a minimum class deemed to satisfy particular types of application. Diagram 40 of Approved Document B defines permissible areas of use on a building for products based on their reaction to fire characteristics. Materials achieving Class O or 0 can be used in the same locations as those achieving Euro Class B. The test methods set out in BS 476 are the ones used to achieve Class 0, and the tests defined in BS EN 13501 are used to achieve Euro Class B. BS 476 and BS EN 13501 test different things, but both result in a reaction to fire classification. Both tests are acceptable when making a decision about reaction to fire when considering diagram 40, and in terms of its application in the approved document, the two classifications are functionally equivalent even if they are different tests. A certificate does not extend to individual applications. It is a summary allowing a designer of a structure to make an informed decision on the performances of a product. A BBA certificate therefore draws the designer's or specifier's attention to the relevant standards applicable to that product, and this includes, but is not limited to, fire safety. It provides an independent opinion as to the performance of that product assessed against those standards. The BBA's processes that lead to this opinion are themselves independently reviewed by UCAS. A BBA certificate therefore affords confidence to a specifier or designer as to the assertions made by a product manufacturer about that product's properties. A BBA certificate provides a summary of the information necessary to make a decision on an individual application. But a BBA certificate must be read in its entirety. They are intended to be technically robust, but also concise. It is self-evidently not possible to fit all of the relevant information required by a designer or specifier on the first page. In a short section in the first page, it will refer to the contents of the certificate itself. The BBA's relationship with its certificate holders is contractual. The certificate is based on the documentary material that is provided by the supplier. The applicant certificate holder pays a fee to the BBA for initial assessment and, if appropriate, certification and subsequent inspections. Pursuant to this contract, the supplier has obligations to make disclosure of any testing that has been carried out. Any changes to the composition of the material also have to be reported under the contract by the manufacturer. The effectiveness of the certification process is therefore based on certificate holders observing the terms of their certification contract in good faith, both during the initial assessment process and during ongoing surveillance, as well as the rigorousness of the BBA's own assessment, certification, and inspection processes. It is particularly important that manufacturers disclose to the BBA all test results and other information that may be relevant to the assessment of the product. The standard certification process of the BBA has been set out in a number of its witness statements and is summarised in its opening statement, and I would refer to the inquiry to that. If I turn to the products, the certified products that are being considered by the inquiry. The BBA had issued certificates in respect of two of the materials used in the refurbishment of Grenfell Tower, which are an issue for this inquiry. Firstly, Kingspan Cool Firm K15. Secondly, Rhinobond architectural wall cladding panels, covering both the standard and fire retardant grades of the product. And the BBA understands that this was marketed as Rhinobond 55 PE. The BBA has detailed in its evidence to the inquiry the process in which those product manufacturers applied for certification, the documentation that was provided with their applications, and the subsequent surveillance, reviews, and updates of the certificates. The two products were first certified in 2008. Kingspan first applied for certification in 2003, and Alcoa, as Arconic was then known, applied in 2006. The evidence, therefore, also shows the evolution of the BBA as an organisation in the time frame since those applications were made, with greater levels of supervision, training and continuing development evolving over time, but within a more formal structure. And this is a process that has continued since June 2017 as well. Turning first to Kingspan K15. The K15 certificate went through a number of reissues from 2008 to 2013 before a new certificate was issued in 2015. The wording of the certificate was changed on each occasion. And so the history of the certification of Kingspan K15 illustrates the different measures that the BBA put in place to ensure the certificate wording is not capable of misinterpretation. On the 30th of October 2020, after the BBA submitted its written opening statement, and before the BBA had seen Kingspan's opening statement, Kingspan wrote to the BBA, advising them that they will be withdrawing 3 BS 8414 test reports from circulation. The BBA has been in direct contact with Kingspan, and Kingspan's opening statement has subsequently been amended as well. The BBA certificate for Kingspan K15 was already in the process of being reissued at the instigation of Kingspan. Pending further information from Kingspan, the current Kingspan K15 certificate has, as a result, been suspended in accordance with the BBA's procedures, and the BBA's website is in the process of being updated to reflect this suspension of the certificate. I'll now turn to Arconic Rhinobond. There was one certificate for Rhinobond architectural wall cladding panels. The history of the information provided to the BBA by Alcoa and then Arconic, compared to the information actually in the BBA's possession, has been of great concern to the BBA. The witness statement of Brian Moore, the former executive director of the BBA, and the first witness statement of John Olwen, head of approvals for construction products, details the information that was not provided to the BBA about the reaction to fire properties of Rhinobond. At the time that Alcoa applied for certification, it had in its possession a report that stated that the cassette version of the product had a significantly worse fire classification rating to the riveted version. Alcoa was aware at the time of the original assessment that the cassette version should have been classified as E at the time of the initial BBA assessment. When Alcoa was presented with draft certificates by the BBA, it did not correct them to show that there was a very significant difference between the riveted and cassette versions. Alcoa never provided this information to the BBA prior to the Grenfell Tower fire. The BBA was not advised in advance of any significant changes to the specification of the product during the lifetime of the certificate. It was, in fact, a BBC journalist who alerted the BBA to the fact that the core to a Rhinobond PE product had been changed in 2015. And Mr. Brian Moore describes in his witness statement the subsequent inquiries that the BBA carried out. In November 2018, the BBA was provided with advanced disclosure of Appendix O of Dr. Barbara Lane's report, which was approximately a month before publication. The BBA was concerned about the discrepancy between the information that Dr. Lane was provided with by Arconic, the information that they had been provided with by Alcoa or Arconic during the certification process. Dr. Lane referred to a number of documents relevant to certification that the BBA had not seen. At the same time, the BBA had further documents that Dr. Lane had apparently not seen. In short, the BBA were not provided with relevant fire test results by Arconic, either when Reynobond was originally certified or when the certificate was subsequently reviewed. Once the BBA became aware of the existence of additional technical information that had been withheld, it entered into a series of correspondence seeking clarification. As Arconic were unable to explain the failure to provide this information to the BBA's satisfaction, the certificate was suspended on the 16th of November 2018 and subsequently withdrawn on the 28th of February 2019. If the information available to Dr. Lane was made available to the BBA, either during the application process or afterwards, the BBA would have either reissued or amended the certificate to reflect the distinction between the FR and PE core and the riveted and cassette forms of the product. Had the reports that Dr. Lane referred to been made available to the BBA, it would have written or updated the certificate to provide the correct classifications and to place these in the context of approved document B. If the BBA had known that the cassette version of the product was Class E and achieved a different reaction to fire classification to the riveted version, which was Class C, the certificate would have shown both the differences between the two versions and reflected those fire classifications. The BBA understands that Reynobond cladding used on the refurbishment of Grenfell Tower had a smoke silver, pure white Duragloss surface coating. As noted in section 6.1 of the certificate, the fire test provided for BBA was in respect of a grey-green Duragloss 5000 coating. The certificate confirmed that these performances may not be achieved by other colours of the product. The Reynobond cladding therefore used in the refurbishment of Grenfell Tower was not covered by a BBA certificate, as that certificate did not cover the colours of the product used on the building. In its opening statement, the BBA has commented on proposals for change. The BBA has made changes to its processes, certificate wording, and training before and after the fire at Grenfell Tower. It has also commented on Dr. Barbara Lane's proposals. Some of the points that Dr. Lane has made, such as the references to Class 0, hinge on the way in which approved document B is worded, and this is not for the BBA as an independent certifier to comment on. Similarly, the BBA does not provide a value judgment as to the merits or worth of different fire testing methods. The BBA has now moved to a position of carrying out its own surveillance across all products. The way in which the BBA trains its staff has evolved, and a significant amount of technical staff's time is devoted to building technical knowledge. The effectiveness of the BBA's training and competence of the staff involved is examined by UCAS, its accreditation body. The BBA does not agree that fire test data and classification reports for a product be provided as part of a certificate. This is to prevent a certificate from becoming overly long or difficult to use. The BBA does now reference fire test reports on which the certificate content is based to enable a specifier to make their own assessment of the results. The BBA would again emphasise that certificates are concise documents and that they must be read in their entirety. As for failed fire test results, the BBA suggests that testing on developmental versions of a product has no relevance to classification. If a particular product has failed to meet a testing standard, but the design is amended so the product then meets the standard following a further test, the original failed test may not be relevant. If, however, a final version of a product has been tested a number of times with different results, the BBA would expect to be provided with these tests, and this is relevant to a product certificate. Again, the BBA is clear in its position that if it had been provided with all of the information in Arconic's possession, both at the time of the certificate for Rhinobond architectural wall cladding panels were issued and afterwards, it would have made a material difference to the content of that certificate. So as to reduce the likelihood of information being omitted from disclosure or presented in a misleading way, the BBA's contracts are being reviewed. The BBA itself has made proposals to support the process of certification and to ensure the information provided to a certification body is as accurate as possible. These are detailed in the BBA's written opening statement, and they are twofold. Firstly, to reinforce the contractual obligation of candour when providing information to a certification body with a duty of fair presentation, buttressed by the criminal law if false or misleading information is provided. This would be an ongoing obligation to cover changes to the certified product. And secondly, to clarify and improve whistleblower protection for an employee of a product manufacturer. To conclude the BBA's opening position, it is important for specifiers and designers to have independent verification of the properties of a product and its performance in relation to prevailing safety standards. This is not only in relation to its reaction to fire, but its other material properties. There are three parts to this, however. The first is that relevant fire safety standards against which a product is being assessed should be clear and relevant. Without this, the yardstick that the certifying body is comparing a product against is not as unambiguous or likely to promote better fire safety outcomes as it ought to be. Secondly, the information that the certifying body is provided with must be accurate and free from material omissions. Thirdly, the systems and processes that a certifying body has in place must be robust, its training and expertise must be of a high standard, and the certificates that it provides must be independent. The BBA will provide its best assistance to the inquiry. It will do what it can to prevent a recurrence of this tragedy. The BBA has closely considered the Phase 1 report. It will carefully consider the evidence presented in this module and will comment as appropriate at that conclusion. And in due course, the BBA will implement any recommendations that the inquiry will propose.
Thank you very much indeed. I think at this point in the afternoon we'll take a short break, and when we come back at 25 to 4 we'll hear from Counsel for the Fire Brigades Union. So 25 to 4 please. Thank you. Good. Well, now the next person to address us is going to be Mr. Seward on behalf of the Fire Brigades Union. So could we have Mr. Seward up, please? Good afternoon.
Good afternoon, Mr. Chairman.
And you can see me clearly and you can hear me well enough?
Yes, I can see you and hear you.
Very good. Well, now you're going to make an opening statement on behalf of the FBU, is that right?
Yes, indeed.
So when you're ready, let's start.
Thank you, Mr. Chairman, Ms. Estevan and Mr. Akbar of the panel, and your assessors, Professor Nethercott and Mr. Montgomery. The Fire Brigades Union, the FBU, remains humbled by the Grenfell Tower disaster and committed to a full and open inquiry with the BSRs at its heart. The documentary evidence disclosed for Module 1 and confirmed by the oral evidence given so far shows widespread ignorance, neglect, and/or complacent assumption amongst those engaged in the construction of the rain screen cladding system for the facades and crown of Grenfell Tower. Both of the increased fire hazards associated with the rain screen cladding system and of the relevant building regulations and guidance in approved document B and of the associated testing, certification and classification regime. It seems no one involved in the construction project thought fire. It was always assumed to be someone else's job, with the result that the increased fire risk of the rain screen cladding system was almost completely overlooked. How did this situation arise? How can it be avoided in future? In Module 2, the FBU understands the inquiry intends to undertake an investigation into the testing, certification and classification of specific external wall materials used on Grenfell Tower, including, as the CTI has confirmed this morning, whether the testing, certification and classification regime was fit for purpose. We note the inevitable overlap with Module 6 and are grateful for that clarification. Dr. Lane has already reported her opinion in section 11 of her main report that the entire building envelope system was non-compliant with the functional requirements of B4 and B3 of building regulations, that some of the cavity barriers used in the refurbishment of GT were not classified for the required fire performance by ADB 2013, and she listed the products, the use of which were fundamentally non-compliant, and thereby provides a focus for Module 2. These products included the Rainabond ACP polyethylene PE cassette panels and the thermal insulation boards attached to the original concrete wall, Celotex RS5000 and Kingspan K15. Also fundamentally non-compliant were several other important products used in the rain screen cladding system. The alu-glazed styrofoam core insulating panels installed between the windows and by the kitchen extract vents, the Kingspan TP10 insulation specified for insulation around the kitchen extract fans, the Celotex and Kingspan polymeric insulation boards, e.g. Celotex TB4000 and Kingspan TP10, used to insulate the window reveals and close the new cavity formed between the old and new infill panels between the windows, and the side-rise Lamitherm RH25G cavity barriers. These all played a part, allowing the spread of fire out of flat 16 back into the other flats as it spread over Grenfell Tower, and these will not be overlooked. Turning to the expert evidence for Module 2, Dr. Lane has confronted the complexities and described the requirements of the building regulations, the guidance in ADB, and the fire tests relating to a rain screen cladding system in Appendix F of her Phase 1 report. She did so to provide a detailed, I quote, a detailed understanding of the requirement at the time of the Grenfell Tower fire, and also to provide a basis for formulating future changes, saying, importantly, what is important now is to remove any means for loose interpretation of the fire safety requirements regarding external wall construction. But the explanatory note issued by the government soon after the Grenfell Tower fire did just that. This was the DCLG's Note 4, which provided another means for loose interpretation by conflating the polyethylene core of the ACP panels with insulation materials by labeling it filler material and thereby applying the requirements in section 12.7 of ADB for insulation materials instead of those in section 12.6, external wall surfaces. Dr. Lane has explained the error of this approach. This note 4 exemplifies the inadequacy of a piecemeal approach to revising the guidance in ADB. For a long time before the Grenfell Tower disaster, ADB needed wholesale review and revision, not piecemeal amendment, to provide the construction industry with useful guidance on how to meet the functional requirements of regulations B3 and B4, 1 and 2, when recladding existing high-rise residential buildings. Rain screen cladding systems can be beneficial by increasing thermal efficiency and keeping buildings dry, but as now seems obvious, they can increase the risk of fire unless carefully designed and installed. The authors of Note 4 did not conquer the complexities of ADB. Neither did those involved in the refurbishment of Grenfell Tower. There must, the FBU submits, be a reason why the designers of the rain screen cladding system at Grenfell Tower, including architects and cladding specialists, did not understand the relevant sections of the ADB. The FBU submits there are 3 major factors. 1, the breathtaking failure of the design team to read and understand the guidance. 2, the complexity of that guidance. And 3, the inadequacies of the testing, certification and classification regime. These issues, like the modules for this inquiry, are all interlinked. They all reflect the culture of complacency referred to in our opening submissions for Module 1. As to the first, the breathtaking failure of the design team to read and understand the guidance, and without repeating the transcript references set out in the FBU's written opening submissions for Module 2, André Kirchel did not reacquaint himself with regulations B3 and B4, and so could not supervise Bruce Soanes. Mr. Soanes had not heard of the phrase limited combustibility and could not recall if he was aware that buildings over 18 meters had different guidance. He did not recall reading Section 9 of Appendix B to ADB during the GT project, and he did not know the potential routes to compliance under ADB at the time of the GT project, and could not confirm which route was actually followed. Neil Crawford assumed it was the linear route, meaning sections 12.6 to 12.9 of ADB, although he never discussed this with anyone. Thomas Reck was not aware of the general principle that insulation in walls of buildings with a story more than 18 meters above ground level should be of limited combustibility, and couldn't define a material of limited combustibility. Kevin Lamb did not know what route to compliance was taken at Grenfell Tower. He knew that insulation products needed to be class 0, but he didn't know they had to be of limited combustibility. Reading the guidance would have helped, and better training for these members of the design team would have helped. As to the second factor identified above, the complexity of that guidance, the inquiry may find the complexity of the guidance in ADB contributed to the Grenfell Tower disaster itself. The complexity is demonstrated both by the misfired Note 4 published by the government post-Grenfell and the widespread ignorance of the design team on the Grenfell Tower project. The existence of so many high-rise residential buildings with what is now recognized to be dangerous cladding up and down the country may support such a conclusion. Dr. Lane and her team have now undertaken a wholesale review of the guidance in ADB, and she has recommended a spate of necessary revisions. The FBU submits the government should have conducted a wholesale review of the guidance in ADB long before the Grenfell Tower disaster, prompted by the inquests into the fatal fires in Shirley Towers and Lakanal House. As to the third, the inadequacies of the testing, certification and classification regime, and commensurate with the complexity of the guidance in ADB, the testing and certification regime was mind-boggling. Dr. Lane describes a range of different testing methods that could be adopted to enable a material or product to be certified as passing either national class standards, i.e. British standard testing, or European standards, and she summarizes them in several tables in her Appendix F. The inquiry may find that this added layer of complexity deterred both the practitioners in the design team on the Grenfell Tower project and those responsible for enforcing the regulations from engaging with the documents, such as BRE 135, and led them instead to rely on the contradictory guidance in diagram 40. No need to read the book, just look at the pictures. The chairman cited with approval at paragraph 23.62 of his phase 1 report the opinions of Professor Bisbee and Professor Torreira, who were at pains to emphasize the complexity of the rain screen cladding system in terms of the interactions between its various components when exposed to fire. The chairman expressed his intention to investigate the extent to which those complexities were recognized and understood by those in the design of the refurbishment, and the extent to which the current evaluation and testing regime is capable of ensuring that they are properly accessed. Consistently with Professors Torreira and Bisbee, Dr. Lane testified last week that with a rain screen cladding system affixed to the facades and crown, Grenfell Tower was a complex building. This should have been recognised at the time by those involved in its refurbishment. Dr. Lane should know that many of the victims of the Grenfell Tower disaster, and I include injured firefighters among them, have read and welcomed her reports and respect her painstaking determination to unravel these complexities. I turn to the public interest in testing these building materials. The chairman of the panel has already confirmed this public interest in his phase 1 report. Central government has long recognised the public interest in understanding how building products react when exposed to fire, testing products with its own research arms, such as the Building Research Establishment, BRE, and regulating the use of building materials. As far back as the Great Fire of London in 1666, the city was rebuilt in accordance with new building regulations, requiring the use of stone and brick instead of wood. The government has long known of the risks associated with cladding systems and the need for proper testing of building materials. MPs took a close interest through the 1999 inquiry on cladding after fires at Knowsley Heights in 1991 and Garnet Court in 1999. The Select Committee reported on the 5th of January 2000 on the potential risks which could be posed by fire spread involving external cladding systems, including a shorter period available for escape from the building, thus potentially endangering life, disproportionate difficulties in firefighting, disproportionate damage to the building. If only those words had been properly heeded. The Select Committee in 2000 noted, and I quote, "The responsible attitude taken by the major cladding manufacturers towards minimizing the risks of excessive fire spread, which had been impressed upon us throughout this inquiry." That's paragraph 18 of the committee's first report. And concluded that all external cladding systems should be required either to be entirely non-combustible or to be proven through full-scale testing not to pose an unacceptable level of risk in terms of fire spread. That's paragraph 20. But the rain screen cladding system constructed for Grenfell Tower met neither of those standards, being neither non-combustible nor proven through full-scale testing not to pose an unacceptable level of risk in terms of fire spread. Where was the responsible attitude impressed upon the 1999 inquiry? How did the cladding industry and all those involved in the GT refurbishment come to assume without proof that highly combustible building materials could be used on high-rise residential buildings, the paradigm of a high-risk building? This brings me to the independence of the certification bodies. Testing, certification and classification bodies should be independent of the construction industry, including the manufacturers of cladding materials. This has long been recognised. For example, in its annual report for the year ending 31st of March 1999, the day it ceased to be a non-departmental public body, an NDPB as they're known, sponsored by a government department, and was then afforded greater autonomy, the British Board of Agrément declared under the heading background, I don't cite it all, but just extracting the relevant bits, the BBA was established to provide construction industry decision makers with independent information on product performance through its Agrément certificates, stimulating safe innovation by manufacturers. Instead, and perhaps relying on the responsible attitude noted by the Select Committee in paragraph 18 of the first report, cited above, these bodies appear to have lost their independence from the cladding and construction industry. Why did this happen? The inquiry may consider it relevant that A, when these bodies lost their public funding, they became reliant upon their commercial sponsors for their running costs. This caused an inevitable loss of apparent, if not actual, independence, and may account for some loss of rigor. B, further evidence of a loss of independence is the involvement of construction product manufacturers on the board of the BBA. For example, Mr. Ankers, Chief Executive of the Construction Products Association, CPA, served on the Board of Governors of the BBA from the 25th of November 1999 until after the Grenfell Tower disaster. Who is the CPA? It claims on its website to be the leading organisation that represents and champions construction product manufacturers and suppliers. Equally, Mr. Harper, a former Group Chief Executive of Celotex Group Ltd, so served from 15th of November 07 until the 31st of March 2016, chairing the BBA's board from 2008. Celotex, in this context, needs no introduction. The FBU asks how, if at all, were these conflicts of interest resolved within the BBA? The BBA produced certificates which beg a belief. Was the noble public interest purpose for which the BBA was established displaced to further the interests of its sponsors from the construction industry? Likewise, the inquiry may consider it relevant to investigate why the BRE allowed itself to be constrained by confidentiality agreements in the use it could make of test fails. Did they safeguard the test sponsors' proprietary information at the expense of the public interest in learning from the test results? The FBU would ask the inquiry to find that the learning from tests, both successful and failed, should have been made readily available to those in the fire safety community, including all the different testing, certification and classification bodies, as well as designers of rain screen cladding systems, fire safety consultants, and those working in building control and in fire safety departments. The FBU hopes the inquiry will investigate the underlying causes for the ignorance, neglect, and/or complacent assumption of most of those involved at all stages of the Grenfell Tower refurbishment. Those underlying causes lie at the heart of the inquiry and may include introducing private approved inspectors in 1984 and extending their use in 1997, amending the building regulations and the ADB guidance from 1985, but failing to clarify the guidance following the Shirley Towers and Lakanal House fires to explain the fire safety requirements of the increasingly prevalent rain screen cladding systems seeking thermal efficiency, but ignoring the correlative increased fire risk. Cuts to the enforcement agencies, both building control, fire authorities and housing authorities, reducing their ability to enforce standards and respond effectively to the new challenges of rain screen cladding systems. Near constant attacks upon the public sector, including fire and local housing authorities. Privatisation of and the encroaching influence of the construction industry upon the testing and certification bodies, the BRE in 97 and the BBA in 99. The lack of publicly funded, non-industry research into changing risks posed by new construction methods and systems. The introduction of the fire safety order, which ignored the structure and exterior of buildings, failed to address the particular fire safety requirements of residential buildings. The introduction of the Housing Health and Safety Rating System in 2004 with no commensurate increase in housing authorities' budgets to enable them to provide enough environmental health practitioners to consider the fire hazards associated with rain screen cladding systems. The concurrent deregulation agenda, making it easy for the construction industry to minimize, yet hard for the enforcing agencies to ensure compliance. The abolition of the Central Fire Brigades Advisory Council in 2004, and the failure of successor bodies to advise on the increasing fire risks associated with thermal insulation and the rain screen cladding systems. Finally, the failure of national and local government and of the testing and certification bodies to monitor the development of risks, as highlighted by cladding fires in the UK and abroad. Although postponed to Module 6, it's imperative that the FBU submit that these underlying causes are then addressed with the same vigour and attention to detail as the inquiry has applied in Phase 1 and in Module 1 of Phase 2. And so, in conclusion, the multiple failures of the testing, certification and classification regime in operation before the Grenfell Tower disaster were due to a combination of the failure of government to undertake a wholesale review of the guidance in ADB, the failure of the testing, certification and classification bodies to retain independence from their commercial sponsors, the failure of the design team to confront and understand either the guidance or the testing, certification and classification regime, the failure of government to regulate the installation of rain screen cladding systems. As presaged by Lady Judith Hackett, as seen with the design and construction companies reviewed in Module 1, the FBU suggests it will become clear in Module 2, in the context of construction product manufacturers and suppliers, that companies cannot be trusted to regulate themselves. Thank you, Mr. Chairman.
Well, thank you very much, Mr. Seward. That was very interesting and helpful. Thank you. Now, our final speaker this afternoon is Miss Studd, Queen's Counsel, who's going to address us on behalf of the Mayor of London. Yes, hello, Miss Studd.
Good afternoon, Mr. Chairman.
Good afternoon. You can. I take it you can see me and hear me. Is that right? Good. Well,
I can.
Good.
Yes.
And we can see and hear you. So when you're ready, we shall look forward to hearing what you have to say.
Thank you. Mr. Chairman, in a letter to the Mayor dated the 3rd of August 2020, you wrote, "The inquiry's terms of reference are limited to matters directly relating to the fire and do not include the influence of social background and race on the allocation of social housing." You went on, "I've always made it clear, however, that if in the course of the investigations the panel finds that factors of that kind played a part in any of the decisions under consideration, it will make that clear in its report." Since the last time the core participants made submissions before you, through the impact of the COVID-19 pandemic, the brutal killing of George Floyd, and the welcome interest in profile of the Black Lives Matter movement, we are reminded of the racial and social economic inequalities present in our society, which must not be ignored by this inquiry as a potential factor in influencing attitudes and behaviours during the Grenfell Tower refurbishment project. The Mayor raises these issues here and now, although appreciating that these matters will probably continue to apply in relation to the later modules in this inquiry. However, it must be at the forefront of any examination of decision-making throughout the inquiry's investigations in relation to its terms of reference. Of the many public concerns that fall to be examined and considered by this inquiry, it is perhaps the visual imagery of the Grenfell Tower cladding on fire on the 14th of June 2017, which remains imprinted in the public memory and causes continuing anxiety to many. The post-fire testing of the cladding and the results of those tests, taken together with the images that we all saw, both at the time and in the aftermath of the fire, has had significant and long-lasting impact on the ability of residents living in buildings with unsafe cladding systems, whatever their height, and throughout the United Kingdom, to feel safe in their homes. Current inquiries reveal that there are 179 buildings in London above 18 metres in height, where aluminium composite cladding still requires removal. Additionally, 2,784 buildings have been registered with the Government Building Safety Fund for the removal of dangerous non-ACM cladding. You can see, Mr. Chairman, that the full scale of the problem is vast. But returning to London, there are a significant number of tall buildings in London. Those who work or reside in them need to know that safety is first priority for those responsible for construction and refurbishment. The financial cost must not be permitted to take priority over safety. During this module, the inquiry will be examining the procurement, use and marketing of the cladding products used at the Grenfell Tower. As Dame Judith Hackett commented in her introduction to her final report, the debate continues to run about whether or not aluminium cladding is used for thermal insulation, weatherproofing, or as an integral part of the fabric, fire safety and integrity of the building. This illustrates the siloed thinking that is part of the problem we must address. It is clear that in this type of debate, the basic intent of fire safety has been lost. Mr. Chairman, it became apparent from the evidence that you heard in Phase 2, Module 1, that the corporate core participants concerned in the refurbishment of the Grenfell Tower may have had different priorities than the safety of the residents and their visitors when they were considering the appropriate materials to use in the refurbishment. Those different priorities resulted in the catastrophic results with which we are now so tragically familiar. Mr. Chairman, you reached a conclusion in the Phase 1 report that there was compelling evidence that the external walls of the building failed to comply with requirement B41 of Schedule 1 to the Building Regulations 2010, in that they did not adequately resist the spread of fire, having regard to the height, use, and position of the building. In fact, your conclusion stated, on the contrary, that they actively promoted it. It will be necessary for this module to look back and understand why it was that combustible cladding came to be installed on the Grenfell Tower. This module, focusing as it does on testing, certification, product marketing and promotion, is fundamental to assessing accountability. The inquiry will have to consider the evidence provided by a number of core participants as to their responsibility for undertaking, evaluating, and making public in their literature the detailed results of fire performance testing and their explanations as to whether, and if so, to what extent, fire performance testing and safety was regarded as being secondary to commercial competitiveness and profit. If, as the Mayor anticipates, this was the case, then the inquiry will need to consider what measures it can recommend that would prevent organisations from adopting such warped and dangerous priorities in the future. This should necessarily encompass both specific recommendations related to building safety and general recommendations applicable to this and other safety critical sectors. It is an unfortunate fact that the demonstrable shortcomings the inquiry is uncovering are not limited to the building cladding sector. In recent years, for example, we have seen aeroplane and car manufacturers putting profit ahead of safety. The effective recommendations made in this inquiry must impact more widely to compel a safety-first approach across all industries within both the public and private sectors. The Mayor has already shared his concerns with the government about the appropriateness of using assessments in lieu of tests or desktop studies as they are more readily known. The inquiry is very familiar with the criticisms made of these assessments by Dame Judith Hackett, both in her interim and in her final report. And the Mayor invites the inquiry to robustly examine this issue and establish how it was that this method, with its lack of transparency and use of inaccurate or inadequate data, came to be used to test suitability of insulation and cladding systems. Looking forward, the Mayor would ask the inquiry to make recommendations to support those made by Dame Judith Hackett, so as to ensure the development of a clearer, more transparent and more effective specification and testing regime for construction products. To that, he would add the need for the results of testing to be readily accessible to the public and open to scrutiny to promote transparency. The Mayor invites the inquiry to make interim recommendations to ensure that vital changes can be implemented with some urgency on grounds of safety. He also supports the government's ban on combustible materials on external walls, but would urge you also to consider a recommendation to ban its use on all buildings, regardless of height and use. The Mayor seeks to lead by example. Since September 2019, in new housing developments on Greater London Authority land, delivered through the London Development Plan, there is a requirement for the provision of sprinklers in new flats, control over the use of combustible materials in buildings of any height, and compulsory registration of white goods to enable effect to be given to a product recall. By way of example, the Mayor will be working with a development partner to build in excess of 800 homes at the St Anne's Hospital site in Haringey, which will be developed under this criteria. The Mayor wishes just to return briefly to what I've said earlier, towards the beginning of this opening, about the scenes indelibly imprinted in the minds of many, but most particularly the bereaved survivors and relatives. In this very emotive part of the inquiry, the bereaved survivors and relatives need and deserve candour, transparency, and honesty from all the relevant core participants. They, of course, remain at the heart of this inquiry, and they need to have their questions answered. Mr. Chairman, that's all I have to say by way of opening.
Well, thank you very much indeed, and we'll certainly be considering all those suggestions very carefully. Thank you. That, I think, brings us to a close for this afternoon. We shan't be sitting tomorrow because we don't sit on Fridays, but we will take up the mantle again on Monday morning when we'll hear further from other core participants making their opening statements. So that's all for today. 10 o'clock on Monday, please. Thank you.